Hi, the video is going to teach you how to write a chart for Sunniesnow. This video will be consisting of two parts. The first part is about SS Charter, the charting tool, and the second part is about Sunniesnow Record, the video generation tool. Notice that the mentioned software is still under development, and it was updated while the video was being edited and after the video was published. Therefore, the video may not be up to date. Also, the video is not intended to cover everything about them, so it is better to learn about them by reading their documentation on GitHub. Or you may want to reach out to me in the Discord server or QQ group. Information is available in the description or the pinned comment. Now let's get started. Before you continue, you need to make sure that you are familiar with the command line interface. If you are not familiar with it, you may find this short introduction helpful. Check out the link in the description. To use SS Charter, you need to first have Ruby installed. You may already have it installed. Run the command rubyv to check. For my case, I have already installed it, and I can see that my Ruby version is 3.2.2. If you don't have Ruby installed, you can look at the official website to see how to install it. On Windows 64-bit, you may just go to rubyinstaller.org/downloads and download and run the installer here. After you have Ruby installed, check again in the command line interface whether the Ruby command is available. If it's not, check your path environment variable. If it already contains the path to the Ruby executable while you still cannot use that command, try restarting your command line shell or your computer. Then you are ready to install SS Charter. Just run the command gem install SS Charter and wait for it to finish. After that, you can run the command SS Charter to check whether it is installed successfully. Now let's decide the music that you want to chart for. For this tutorial, I will use Big D by Shaolin Dub. Here I have downloaded the music file and the cover image. The next step is to create an SS Charter project for this chart. Run the command SS Charter init Big D appended by the audio and image files. The Big D here is the name of the project. After running that command, you can see that there is a new directory with the name as your project, and there are some files inside. The audio and image files are copied into the file subdirectory, so you can delete the original files if you want, and you can add or replace files here if you did not specify them correctly when creating the project. Let's see the directory structure of the project. Gem file specifies the gem dependencies of the project. By default, your project depends on SS Charter Bundler and Rake. You can add more dependencies if you want. .gitignore specifies the files that should not be tracked by Git. If you do not use Git as the version manager for a project, it does nothing. Rake file contains some tasks that can be run by Rake. readme.md is the readme file of your project. .sscharter.yml is the SS Charter configuration for your project. Files is the directory whose files will be included in the final level file. You can change the directory in .sscharter.yml. src is the directory that contains some source codes of your project. You can change the directory in .sscharter.yml. In this video, we will mainly focus on the files in src. There is already a file named master.rb in it. The file name does not matter. You can name the source code files there whatever you want as long as they end with .rb. The file names only affect the order of the source code files being loaded. Now let's see what is inside master.rb. These source codes are written in Ruby, or if you would prefer, in a domain-specific language or DSL. Currently, they mostly just speak for themselves. The master here means that the chart we are currently opening for editing is going to be named master.json in the generated level file. Then here is basic information including title, artist, charter, difficulty name, difficulty color, and difficulty. Let's edit the basic information. I will change the title to Big D, the artist to Shaolin Dub, the charter to Ulysses Zhan. Now you may want to see how our source codes may take effect. Run the command rake in the project directory to build the level file. The level file can be found in the build subdirectory. You may change the directory in .sscharter.yml. Let's try playing the level in Sunniesnow. Go to sunniesnow.github.io/game and upload the level file here. As soon as you start playing the chart, you can see that the title is indeed changed to Big D, meaning that our source codes are working. There are currently 2 nodes in the chart, but they were not placed by us. They were placed by SS Charter by default. We need to replace them with our own nodes. Here comes the main part of the tutorial for SS Charter, how to actually write a chart, including placing nodes, tip points, and other events. Before that, you had better have some knowledge about programming. If you do, then you should be fine because Ruby is a very easy to learn language. If you don't, you may want to learn some basic programming first. This short book is a good start. Check out the link in the description. Also, you may need a good code editor. If you have paid attention to the video, you may notice that I am using Visual Studio Code. It is okay to use other editors. Also, to help you pick sounds, you may want to use a good audio editor. Here I am going to use Audacity. The first step of rhythm game charting is always finding the offset and BPM of the music. We can find the BPM by dividing the number of beats by the amount of time passed between them. For example, we can clearly see that the 16th beat is at 6.996 seconds and the 414th beat is at 180.044 seconds. Therefore, the BPM is 138. To find the offset, we just need to extrapolate the data to get the time of the 0th beat, which is 0.090 seconds. To write the offset and BPM information in SS Charter, we need to use the offset and BPM methods, modify the data in the source codes, and run rake again to build the level file. If you play the new chart now, you can see that the 2 notes are now correctly placed to the beats. It is cumbersome to rebuild and re-upload the level file every time changes are made. Fortunately, SS Charter provides a way to automatically rebuild the level file when you make a change, and you do not need to re-upload the level file manually. Run the command rakeserve to start a local server that will automatically rebuild the level file and serve it so that Sunniesnow can access it. Now that we have set up a convenient workflow, let's start actually writing some notes. Write these codes to place some notes. You can pause the video to read the comments to see what they mean. Basically, they just mean that we are placing some hold notes at various positions and beats. Then, let's see what we have got. As we can see, the nodes are placed expectedly. Here are 2 notices. First, the coordinate system of Sunniesnow is a Cartesian coordinate system, with the origin at the center of the screen, the x-axis pointing to the right and the y-axis pointing to the top. Although Sunniesnow can handle arbitrary coordinates, the convention is to keep all the nodes inside the rectangle with x ranging from -100 to 100 and y ranging from -50 to 50. Second, the beats should be specified in rational numbers. This is what the trailing R in the numbers comes from. It is how you write a rational number literal in Ruby. Using rational numbers is important because it avoids rounding errors, making sure that the nodes that you intend to be simultaneous are precisely simultaneous so that the simultaneity hints will be correctly displayed by Sunniesnow. The hold method and the beat method, which we have just used, have short forms H and B respectively. In practice, you may want to use the short forms to save some typing. Also, you can use the semicolon to separate multiple statements in one line. This can make your codes look more compact. We have only covered hold nodes now, but there are also other types of nodes. There are totally 4 types of nodes in Sunniesnow: tap, hold, drag, and flick. You can count background nodes as the 5th type of nodes. For the sake of brevity, I will not cover all the types of nodes one by one, but I will show you a table that summarizes them. You can pause the video to read the table. The values after the equal sign in the arguments are the default values if you do not specify them explicitly. Here I also need to specially talk about how you specify the direction of a flick node. There are 2 ways to do that. The first way is to use a number specifying the angle in radians. 0 is to the right and the increasing angle is counterclockwise. For example, let's change the nodes that we currently have into flick nodes. The 0 angle is to the right, and pi over 2 is to the top, and pi is to the left, etc. If you play the chart now, you will see some flick nodes in those Z directions. The second way is to use a symbol specifying the direction. There are 8 different symbols, namely right, up, etc., and you get the idea. For example, let's change these nodes into flick nodes and specify their directions using symbols right, up, and left. If you play the chart now, you will see that the flick nodes are in the directions that we have just specified. Another type of event that a Sunniesnow chart has, other than nodes, is background patterns. There are totally 8 different kinds of background patterns. Here is a table that summarizes their names and syntax. You can pause the video to read the table. For the big text pattern, you need to specify the text contents as well as the duration, and for others, you just need to specify the duration. Let's try adding a grid pattern to our chart. Write grid 8 here to add a grid pattern with a duration of 8 beats. If you play the chart now, you will see that the grid pattern is displayed as expected. The next topic is groups, duplicates, and transformations. We have already written the chart for the first 8 beats of the music. If we want to repeat the chart for the next 8 beats, how can we do that? An obvious solution is to copy and paste the codes we have written. However, this has some drawbacks. First, if at some point you want to change the pattern, you have to change it at multiple places. Second, when you read the code, it wouldn't be obvious at a glance that the two parts of the chart are actually the same. There are two better ways to do this. The first way is to define a method that contains the codes and then call the method twice. As an example, we named the method as pattern. Let's modify our code to define and call the method and see what we have got. As can be seen, we successfully repeated the chart for the next 8 beats. Another way to do this is to group the nodes together into a group and then duplicate the group. After we duplicate the group, the duplicated nodes are still at the same time as the original nodes. We then need to translate those duplicated nodes in time by 8 beats. SS Charter provides the group method to define a group, the duplicate method to duplicate a group, and the transform method to transform a group. Let's modify our code to use this way to duplicate the chart. As can be seen, we successfully repeated the chart for the next 8 beats. The transform method is very powerful. It can also be used to transform the nodes' positions in space, such as translating, mirroring, scaling, and rotating. Here is a table of some of the transformations that the transform method is capable of. You can pause the video to read the table. We can modify our code to let the latter 8 beats of the chart to be the horizontal flip of the former 8 beats. As can be seen, nodes' positions are indeed flipped. Moreover, the flick nodes' directions are also flipped. The next topic is navigating among beats. We have already known that using the beat method, or abbreviated as the B method, we can navigate to another beat relative to a previous beat, whether forwards or backwards. Using the beat method without arguments can be used to get the current beat. We can try using it in our code to see what it does. As can be seen, they output the expected results. Another useful method is the beat exclamation mark method, abbreviated as the B exclamation mark method. It sets the current beat directly instead of specifying the amount of beats to proceed relative to the current beat. Having beat exclamation mark, you can travel back to some point in the past to write some notes there. For example, we can write double notes like this. As can be seen, the double notes are placed as expected. Another way to do a similar thing is to group the notes in a way that does not preserve the beat. We can tell SS Charter that the current beat should come back to where it was before the group was started by adding a keyword argument, preserve beat, in the call of the group method. Then here's the last topic of this section, tip points. There are mainly two methods for adding tip points, tip point chain and tip point drop, abbreviated as TP chain and TP drop respectively. Their syntax are the same, but they have different effects as illustrated in this diagram. Namely, TP chain chains all the nodes in the group with a single tip point, and TP drop gives each node in the group a tip point. The usage of TP chain and TP drop is very similar to that of group, but they require additional arguments to define when and where the tip point is spawned. First, let's talk about how to define where the tip point is spawned. There are two ways to specify the spawning position, relative and absolute. The relative way is to specify the spawning position relative to the position of the first node that the tip point is connected to. The absolute way is to specify the spawning position directly. The two ways can both be used with both TP chain and TP drop. The keyword argument relative is used to specify whether you want to use the relative way or the absolute way. And if you do not specify it, by default it is true, meaning that the relative way is used. Then let's talk about how to define when the tip point is spawned. There are 4 ways to specify the spawning time: relative, speed, relative beat, and beat speed. Only one of the 4 ways can be used at a time. This diagram illustrates their usage and meanings. I hope it is illustrative enough so that I don't have to explain them one by one in words. Here is a table that summarizes the arguments of TP chain and TP drop. Let's try modifying our codes to add some tip points. Note that, like group, methods TP chain and TP drop also return the grouped nodes, and we can duplicate and transform the group. They also accept the preserve beat keyword argument like group. We can also see that the spawning position and time of the tip points are also affected by transformations done by the transform method. These are all the things that I want to talk about SS Charter in this video. If you want to learn more about SS Charter, you can read a more comprehensive tutorial on GitHub. You're also welcome to join the Discord server or QQ group to reach out to me to ask any questions about how to use SS Charter. The links are in the description or the pinned comment. Now let's move on to the second part of the video, Sunniesnow Record. Sunniesnow Record is a tool that can generate a video from a Sunniesnow chart. To use it, you need to have Node.js 20.6 or later installed. You can check whether you have it installed by running the command node-v. Here I have the version 20.10.0 installed. If you don't have it installed, you can go to nodejs.org/en/download to download and install it. Remember to check whether the node command is available after installation. You also need to have ffmpeg 6.1 or later installed. You can check whether you have it installed by running the command ffmpeg-version. Here I have the version 6.1.1 installed. If you don't have it installed, you can go to ffmpeg.org/download.html to look for a suitable download link for your platform. Remember to put the executable file in a directory whose path is in the path environment variable, and then check whether the ffmpeg command is available after installation. Then you can install Sunniesnow Record by running the command npm install-g Sunniesnow Record --legacy peer depths. After the command finish, you can run the command Sunniesnow Record --help to see whether it is installed successfully. Then let's use Sunniesnow Record to generate a simple video. There is a very short sample chart for Sunniesnow called Sunniesnow sample. Let's try generating a video for it by running this command. Then after some time, depending on your computer's performance, you will see a video file named output.mkv in the current directory. You can watch it to see what it looks like. We can also try generating a video for the chart that we have just written. Run Sunniesnow Record --level file upload appended by the path of the build level file. Then after some time, the video file will be generated. That's all for this video. Again, do not hesitate to reach out to me to ask any questions. Thank you for watching.